For problem number 67, the question asks us which of these functions do intersect their horizontal asymptotes. Now, for the first function, letter A, which is graphed in blue here, we know that the horizontal asymptote, since this is bigger on the bottom, is going to be y equals 0. So I graphed y equals 0 as the horizontal asymptote as this dotted line here on the x-axis. Now you can see pretty clearly from the graph that this does cross at 0, 0. How do you confirm that without a calculator? This one you could do without a calculator if you wanted to. All you have to do is know that x over x squared minus 1 is supposed to have a y value of 0 when the x value is 0. And since the horizontal asymptote is y equals 0, we're going to put a 0 where the y typically goes in the function. If you solve this equation, you're going to multiply both sides by x squared minus 1, which is going to give you a 0 over here on the right-hand side, and on the left-hand side you get x equals 0. So when we made y equals 0, we saw that x equals 0. So we've confirmed both graphically and algebraically that this function does indeed cross its horizontal asymptote. Let's look at another one. Here I've graphed in green x divided by x squared plus 1. This is number 67, letter B. So once again, you can see visually that the horizontal asymptote is y equals 0. You can tell using our strategies that we've talked about that the horizontal asymptote is y equals 0 because the exponents are bigger on the bottom. And to prove algebraically that this does indeed cross its horizontal asymptote, we're going to set the equation equal to 0. When you solve this, for x, you're going to multiply both sides times x squared plus 1. And over here, these are going to simplify to 1, and you'll get x squared equals 0, because 0 times anything is 0. The square root of both sides will show you that x equals 0. So when you substitute in a 0 for y, you get a 0 for x. So we have shown that this one also crosses its horizontal asymptote visually on the graph and algebraically. Now for the last one, you can see that this one appears to cross its horizontal asymptote, or at least touch it. And to prove it algebraically, once again, we're going to set the equation equal to 0. Multiply both sides by x cubed plus 1. And this simplifies to 1, this simplifies to just 0, and you get x squared equals 0, and you see once again that if y equals 0, x equals 0. So that's how you can demonstrate this algebraically and also see it visually on a graph. Remember, to use this graphing tool, you just go to Desmos.com. It's also an app that you can download on your phone or tablet.